Okay, then, right, I think I'm ready to start. Okay, question 1. So you should have the paper in front of you. There should be a link to it in terms of on the YouTube channel. And it says, the points A, B, and C are such that A, B have coordinates -4, 7, and 2, -1, respectively. And C is the midpoint of AB. The line L is perpendicular to the bisector B. So there's loads of important bits and bobs going on there already. Probably for me, the first bit to work out would be the coordinates of C, although it says find the gradient of AB. Okay, so for number 1, I would do for my gradient of AB, the way that we have learned it is we have said that it's dy by dx, which stands for the differences in y's divided by the differences in x's. So what I'm going to do as well, just to make things slightly easier, I'm going to write out those coordinates up here as well. So hopefully I don't do anything the wrong way around, but that's where the biggest mistakes are. So the differences in y's of a and b. So I'm going to do 7 minus -1. And then because I did 7 minus -1, I've got to go -4 first this time. -2, which would give me 7 add 1, which is 8, and then -4 -6 with the -2 altogether. Now that is fine, but you can obviously cancel that down. In terms of where you put the minus, I just put it by the side of the fraction, -4/3. For part B, I can work out here that the midpoint of AB equals C. So all I'm going to do is add the x coordinates together. So -4, add 2, and then take the average. That's what the midpoint is. Comma, 7, add -1. And again, take the average of that. So that would then give me the coordinates for C being -4 plus 2 is -2. Half of that is -1. And 7 add -1 is 6. And then 6 divided by 2 is 3. So my coordinates for C are -1, 3, which I'm going to write up by there as well. Right then. So for the next one, it says by the side, I'll show you what I can see. It says show that the equation of L is this thing here, and I love it when they give us what it's supposed to be, because that means if I haven't got that, I've made a mistake up here. Right then. So if I do that, I need to use a formula. So for part C, I need to use the formula y minus y1 equals mx minus x1. Now, I'm doing this for the equation of L. So for the equation of L, I need to go back and read the question. It says that L is the perpendicular bisector of AB. So I need to work out this gradient here. So the gradient, m, using this equation, is not... it's not going to be the -4/3 from up here, because that is the gradient of AB, and it's perpendicular to that. So the rule that I'm using is that the coordinates have to times, or not the coordinates, or the gradients have to times together to make -1. So if you flip this fraction, so that would be 3/4, and then one of them has to be minus. That one already is minus. This one isn't. That is going to be my gradient. And that is because, and it's important you state why that's the reason. You can't just say it is, because -4 over 3/4 equals -1, and that is my condition. Can't quite see what I'm writing here, can you? Condition for perpendicular lines. So shorthand way of writing perpendicular is to just show that it's got like a right angle like that for perpendicular lines. Okay, so now I can start subbing in elements of information that's within that. So the way I'd start is the equation of L. L is perpendicular to AB and it goes through C. So I need to sub in C's coordinates. So that would be y minus 3 equals 3/4 of x minus -1. Don't like this fall here. So I'm going to take that over to the other side, and it is going to become a times instead. So I times everything on this side here. So 4 brackets y minus 3 is equal to 3x plus 1. And then I'm going to get 4y minus 12 equals 3x plus 3. So now I'm coming back to what the question looks like. So the question was positive and the 4y minus. So I'm going to bring everything over to the other side from here. So I'm going to leave nothing on this side. So I have the 3x. That would then become a minus 4y. And that minus 12 would come over and become a plus 12. So plus 3 plus 12 is plus 15, which was what they had. So I always write as required. Okay. For part D, we are told that the point D lies on L and has the coordinates 7k. So it has the coordinates 7k, where 7 is what x is, and k is what y is, because our coordinates was written x and y. I'll move it so you can see a bit better. So from here, because this lies on L, what I can do is I can sub in these coordinates into the equation I've just got to then work out what this missing value is. So I'm going to sub in x in place of x, I'm going to write 7, and in place of y, I'm going to write k. So I have 0 equals 3 times 7 minus 4 times k, so 4k, and then plus 15. So 0 is equal to 21 minus 4k plus 15. Take the minus 4k over, so it becomes plus 4k equals 36, k equals 9, which is what it asked me to prove in the first bit. So that's part 1. For part 2, it says find the length of CA and of DA. So to do that, you're basically using Pythagoras Theorem. To work that out, it might be an idea actually for me to start a new page and start drawing bits and bobs onto like a little drawing. Some teachers will suggest that you do that right from the start. As you do more of these, the more confident you get, you don't feel you need to do them that much. So if I started to look at this, so I've got A, which is minus 4, 7, so somewhere around there. I've got B, which is 2 minus 1, so somewhere around here. C, which is the midpoint, so that's around there. And then I've got this D point, which is 7, 9, which I know is on C. So I know that's just a straight line. I know that the line L is perpendicular to that. So it would make a right angle there. I know D is like 7, 9, so D is going to be up here somewhere. And what it's asked CA is to do is use diff in y's squared plus the difference in x's squared, and then square rooted is what the length of a line is. So that's basically Pythagoras Theorem. So for CA, it is going to be, so I'm just looking at the coordinates now of what I've already worked out. The difference in the x's and the y's is going to be 3 squared plus 4 squared. So that is going to be the square root of 9 plus 16, which is the square root of 25, which is 5. Okay, and then similarly for DA, that is going to be difference in y's squared, and then adding the difference in x's squared. So that would be 11 squared plus 2 squared, which is 121 plus 4, which is 125, which in surd form, I know 25 goes into that, so that would have the square root of 25 would be 5. And then still in the square root, 25 times 5, so it would be 5 within the square root here. Okay, so looking at the diagram there ahead, looks about right. CA quite short compared to DA, which is quite long. Okay, then, so the next and final bit for this question, part 3, it says, hence show that the value of sine ADC may be expressed in the form 1 over root A, where A is an integer whose value is to be found. Now, it sounds really, really, really tricky, this part, but it's really not that bad. You're looking at a right angle triangle. There's DA, there's CA. We've just found the values of those. They're probably going to come in handy. So this was 5 root 5, and this was just 5. We don't know what the length of this thing here is, so I'm just going to leave that blank. And it's asked it for ADC. So if I just show you the paper, ADC. So that means A to D would be this angle here, and then to C. So if that's the angle I want, then this would be the hypotenuse because it is opposite the right angle. This would be opposite because it's opposite the angle, and this would be the adjacent. And it's not the adjacent that I've got. I have got the hypotenuse, and they're opposite. So using, let me just show you what I'm doing, using Sohcahtoa, because I've got the opposite here and the hypotenuse here, I know that the sine of ADC, basically that angle there, would be equal to the opposite divided by the hypotenuse. And I know, because I've already worked it out, what the lengths of those things are. So sine ADC is equal to the opposite, so that's 5 over 5 root 5. And again, sorry, let me make sure you can see. Because 5 goes into 5 once, we've got it in the form 1 over root 5, which is exactly the form they wanted. They said get it in the form of 1 over root A, where A is a value to be found. So in our case, A is equal to 5, because that's what's in there, but you don't need to write that down. It's fine to leave it as that. Okay, right then, number 2. So number 2 is the third question, so I'll write it down first, which is 7 plus 2 root 11. Okay, so when we are completing surds questions, when you have something like this, it's called rationalizing the denominator, because the surd is on the bottom. We don't like surds to be on the bottom, we prefer it when they're up on the top. So the way that you get rid of it is that you times by like the difference of 2 squares on the bottom. So you're going to times this by 7 minus 2 root 11. So literally it's exactly the same thing, but the sign just changes. But because this is a fraction, whatever you do to the bottom, you have to do to the top. So that's also times by 7 minus 2 root 11, and it just becomes one big fraction that you multiply out. So if I do that by here, 10 times 7 is 70, minus 10 times 2 root 11, so the 10 just times is the thing outside the root gets left alone, so that is minus 20 root 11. And then that would be all over 7 times 7, which is 49. 7 times minus 2 root 11, so that would become minus 14 root 11. And then plus 2 root 11 times 7, so that would be plus 14 root 11. And then plus times a minus would be a minus. 2 times 2 is 4. And then root 11 times root 11 is just 11. So I need to do 4 times 11, which hopefully you can just about see there. Now, the idea of doing this is that it will always cancel out the roots on the bottom. So they're gone now, because you had minus 14 root 11 plus the 14, they cancel. So I get 70 minus 20 root 11, and that is 49 minus 44. So that would be 5. And then the idea is usually, if it doesn't, it's not necessarily an indication that you're definitely wrong, but if it doesn't quite fit in perfectly, you probably have made a mistake somewhere. So because 5 goes into 70 and 20, I'm feeling pretty confident this is right. 5 goes into 17 14 times and into 20 4 times, and then that would be root 11, and that's your answer. Okay, and for part B, it says 4 root 3 squared minus root 8 times root 50, and then minus 5 root 63 all over root 7. Okay, so I'm definitely going to write a paper here, so I'll start getting ready to go on to the next page. So first of all, I can probably squeeze in one line here. Your 4 root 3 squared, that's going to be 4 times 4, because it's times by itself, so that's going to be 16. Times by, and then root 3 times root 3 would just be 3. So I'm just going to leave it at the moment as 16 times 3. This one here would be root 8 times root 50. So you just do 8 times 50 and leave it in one big square root. So 8 times 50 in there. And then the same here, you do 5, you leave that outside, and then it's the square root of 63 divided by 7. Okay, so going on to my next page. Camera should come back now. Sorry, just having a bit of a problem with the camera here. Let me try again. I'm terribly sorry about this. This seems to have gone faulty for a second. Let me try it in a different USB slot. And let's try it again. Any joy? No. Right, what I might have to do, I might have to restart the broadcast, sorry. It's a bit annoying. You give me one moment, please. Right, it's picking up there, so why isn't it picking up on the other one?